What's going on, everybody? This is going to be a short lecture today. This one is over stoichiometry. We're going to start with the very beginning of the stuff that we actually care about. There's only really going to be one slide of notes, and then I'm just going to work out two examples in this video. Hopefully the transition between cameras actually works. If not, well, I guess I'll be re-recording this so you won't actually hear this part. You may be wondering why there's a picture of grilled cheese right here. That will actually come up later on in this section. It'll actually, hopefully at least a little bit, make some sense whenever we get to there. I may use a different example instead of grilled cheeses though, so maybe this is going to be Chekhov's grilled cheese and you'll never actually get to do anything with that grilled cheese. But regardless. So you might have noticed in last section that when we talked about Avogadro's number, it is actually a conversion factor for moles. 1 mole, if we look at our 1 mole on bottom right here, is equivalent to 602 sextillion, or 6.02 times 10 to the 23rd, of something. That means if we either know the amount of something, or we know the number of moles of something, we can determine the other piece. Now, you could do this with anything. We could do, like, you have 2 moles of pennies, in which case you're, like, super duper rich, as we talked about later, like, earlier on in this notes. Or you could say that you have 10,548,000 of something, and you want to know how many moles of that you have. You could also do that, but we are going to stick with using atoms and molecules. Remember, both of those are particles. So if it asks for particles, if it asks for atoms, if it asks for molecules, or if it asks for formula units, all of those are examples of particles in this case. So this is going to be the first piece of our stoichiometry puzzle, as I cut that off by moving my mouse too far down to the bottom of the screen. So we're just going to do 2 examples. How many particles are in 6.32 moles of argon? And then you have 2.34 times 10 to the 25th particles of sodium in your french fries, which is a lot of sodium. I think I made that number up. How many moles of sodium is that? So let's go ahead and transfer to our other camera. There we go. Now, our first example, or the first question that I had, and this is just work from advanced chemistry, so don't pay any attention to that. How many particles in 2.32 moles of argon? And this is just a conversion factor problem. We have a 2.32 moles. 2.32 moles of argon. Argon symbol is AR. I apologize for my focus on my cameras being a little off. I may have to fix that. So we'll put our dimensional analysis box. We now have moles of argon on top, and we want to cancel that. We want to get particles on top. So we'll need to put moles on the bottom and particles, because we do have a direct conversion factor for that. We can go 1 mole is 6.02 times 10 to the 23rd particles. Let me see if I can adjust my camera real quick, just to hopefully make this a little nicer. Just a little bit. Just a touch. Just a skosh. Ah, that's why we were auto-focusing, and I tried to no longer autofocus. There we go. Okay. Hopefully that's much better. Looks a lot better from my screen, at least. So hopefully it looks a lot better for your screen. So we're just going to plug this into our calculator. I'm going to go ahead and get my calculator out, and we'll actually put it on screen just so you can make sure that you know how we're plugging it in. So we're going to do 2.32. This one's actually easy because even though you've got a scientific notation number, you are multiplying by it, and it's the only piece. So we're actually just going to do times 6.02 times 10 to the 23rd. You could use the E button. I'm just going to use the little up caret button thing. And you get this big number. Remember, E24 means times 10 to the 24th. So our long answer would be 1.39664 times 10 to the 24th. But we want to do sig figs for this. 2.32 has 1, 2, 3 sig figs. So we're going to go 1, 2, 3. We're going to round there. 6 will round us up, so this 9 would actually become 10, which means our correct sig fig answer would actually be 1.40 times 10 to the 24th. And then do not forget your units. So this is particles of argon. And stating that it is a particles of argon is actually going to be important later on. So make sure that you get in the habit of putting that up there. Okay, second example. We have 2.34 times 10 to the 25th particles of sodium, of Na. And it wants to know how many moles. We're going to do the same conversion factor. And this is a 2.34. That looks kind of like a 9, so 2.34. So to convert, we're going to start with our particles, put those on top. 2.34 times 10 to the 25th particles. And we're going to do the same conversion factor, except now we're going to have to put it on bottom. We want particles on bottom, moles on top. 1 mole is 6.02 times 10 to the 23rd particles. Now you might think, okay, well, this is only like 2 bigger than this, so this probably is not going to actually be that large of an amount of moles. So let's go ahead and plug it in. This time you do definitely want to put your number in parentheses. Otherwise, if you don't, it's going to try to, if you do 2.34 times 10 up arrow to the 25th, and then you just keep going, it's then going to divide 25 by this and make that your exponent, so you would get a really, really tiny number. I'll show you what that looks like in a second, though. So we're going to do 2.34 times 10 to the 25th, close my parentheses, divided by parentheses 6.02 times 10 to the 23rd. And you get 38 point. Let's see, get that off my screen so you can see it. 38.87043189, which we are going to round to 3 sig figs, 2.34. So 1, 2, 3, 7 rounds us up. So our answer to the correct sig figs is 38.9 moles of Na, which is a lot. That is a lot of moles of sodium. You'll actually, later on, you'll learn how to figure out how much weight of sodium that is, and that is like way too much sodium on your fries. You should not have that much sodium on your fries. Now, if we had not done parentheses, so if I go in and delete all of my parentheses, sometimes this works out. I don't think it will work out in this case, though. So you get 3.887043189 times 10 to the 47th power. Now, it's possible that you have something that big if you're working with, like, the moles of something on Earth, but you should never get a number that big. This is an unreasonably large number. This would be, like, if we converted this to grams of sodium from this number, this would be a pile of salt literally bigger than the Earth. And that is not, obviously, what we're looking for in this case. So if you ever get a number that's either really, 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 really big or really, 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 really small, you should think in the context of the questions. Are you talking about particles? Because particles should be a big number. They're really, really tiny. Are you talking about moles? Well, moles has a lot in it, so you probably shouldn't get a moles number that's this big. That doesn't really make as much sense as some of the other examples that we've talked about. There should be linked in this day a worksheet that you can start working on. I'm going to have probably all of the worksheets, or at least the next couple of worksheets, due all together because they are really, really closely related to one another. If you have any questions, as always, put them in the box to the side. Send me an email. I hope you're having a great day, and you will probably hear from me soon.